welcome to another episode of Undercool. Today, we're really lucky that we've got Chris Gordon, who's the director of the Wilson Student Project Center here at the University of Michigan. And he's going to tell us all about the Project Center, the pedagogical value of projects for engineering students, and why students should demand this if they're not already getting it. We're sitting here in the Wilson Project Center, so it might get loud once in a while, but that's okay. And we'll show you around a little bit during this podcast. So I'm going to let Tim ask the first question.
Yeah, the first and most important question. Please tell us about yourself.
Yeah.
Who are you? How did you get here? What's your current role? And introduce us to the space a little bit.
Yeah, well, thanks, Tim and Steve, for giving me the opportunity to join the podcast. It's really exciting. And my journey here is maybe a little unusual for an academic institution. I started out, I grew up here in Ann Arbor and the Irish Hills out in Brooklyn. I came to the U of M as an undergrad. I was an aerospace engineering undergrad, actually in this building. So where the Wilson Center is located, it was an undergraduate propulsion lab when I was a student here in the 80s. I actually have a long history at the university. My family, I'm the fifth generation of my family to attend the university.
So did you start back in 1813 with the inaugural class?
Actually, my great-great-grandfather was a philologist and, studied cultures and languages. He was a Greek scholar, and he was a dean of LS&A in the late 1800s. His family emigrated from the Netherlands, I think in 1851. They were Huguenots and came here. So he studied and worked here. My great-grandmother went to education school here. My grandmother and her brother both went to school here. My mother graduated actually when I was in middle school, kind of late in life, got her BGS. And then I came through Aero, and my daughter was the sixth generation. She graduated from the program in International and Comparative Studies. So it's been an amazing journey, but I never really set out with this explicit goal of kind of continuing this legacy. It just kind of worked out that way, and it's an amazing institution. But my career before I came to the Wilson Center, I went to aerospace engineering here as an undergrad on a Navy ROTC scholarship. And so I had set my sights early in my life on being a pilot in the Navy. I grew up around flying. My dad and my grandfather and my uncle were all pilots, and I spent most weekends as a kid out at the Ann Arbor airport. And so I had this real focus on aviation and a career there. And so I went to ROTC, fortunately got selected to be a pilot. And so I flew in the Navy for about 14 years, off aircraft carriers. And then I went sort of on a staff path. I did 2 staff tours in Europe at NATO in Brussels, and then to be US Navy headquarters in Naples, Italy, working with European and African partners. And then I came back here and finished my career at the ROTC unit, kind of where I started out. And when I retired in 2011, the Wilson Center had just finished a significant expansion, thanks to a gift from Vince and Gloria Gogers and their family. So that was the time they were transitioning from a part-time faculty director to they wanted a full-time director to kind of fill up the space and sort of expand the reach of the Wilson Center, and that coincided with my timing. And I convinced the hiring committee, James Holloway was the associate dean at the time who hired me, and I convinced them that you didn't have to be a machinist to run a machine shop. So fortunately, I had a compelling story about my experience helping lead a lot of sort of highly motivated and mission-driven young people, in the military. And I also had an experience as a safety officer where I did, aviation safety programs and mishap investigation. And that was tied in with a lot of experience with risk management. And I think those things came together and got me the nod here. And so I've been here at the Wilson Center since 2011.
I can't imagine many jobs that have higher stakes than taking off from the deck of a carrier. So I imagine you are well qualified to handle a little stress.
Actually, I don't think taking off is nearly as hard as landing in a storm at night.
At night, yes. Yeah. Anybody that tells you they enjoyed landing at the ship at night is lying. It's just all hard work. Yeah. It was a really exciting pathway to get here, but the compelling thing about being here is seeing what our institution trusts our students to do, right? And being given the opportunity to kind of provide this space and the resources for the students to do that. And that's really kind of what the Wilson Center does, the Wilson Student Team Project Center. So it opened originally in 1999. So we celebrated our 25th anniversary last fall. And I mentioned we made a significant expansion around 2011 when I came here to double the size of the space from 10 to about 20,000 square feet.
That's fantastic. So what exactly is the Wilson Project Center and what goes on here?
Yeah, so the Wilson Center, as I would sort of just alluded to, it's first and foremost kind of this big physical space. And we have, this one large coherent facility, and then we also manage a partner space in our robotics department, a maker space there that's about 3,000 square feet, where we have a few project teams. And it's really primarily a home for these project teams. And when I say project teams, they're primarily student organization-based, competition-based projects. So we think about, the project behind us, the Mars rover team. There's 2 international competitions every year that invite, projects from all over the world who, students who build these vehicles to come and compete against each other. And those are the primary kinds of projects that we support. So right now, we have about 25 of those kinds of project teams that we provide a physical home for. So a good analogy, the Wilson Center is a bit like a dormitory. So we've got, all of these individual rooms that we can assign, to different project teams. We also support other kinds of projects that are co-curricular that might have a closet or a shelf instead of a whole room. But we still want to provide them with support. We partner with our Multidisciplinary Design program, some of our capstone design courses, and a few other projects that are not strictly competition affiliated that maybe have different timelines that we support. So that's really the primary thing when you walk in the Wilson Center is what you see is all of these spaces full of projects. And then we also have, the kitchen of the dorm. So we have, machine shop, a lot of tools and other equipment that we make available for the students along with the training to support their use of that. And I'm careful to say we have a kitchen and not a cafeteria because that's really what we provide is let's teach you how to use these tools to create what you need for your individual projects instead of actually creating those things for the students. And we do have sort of a small cafe, I guess, sort of an approach that we use in robotics with some of the tools there. A lot of the 3D printers, we have those in kind of a queue system because it seemed a lot more feasible to make students accessible to that by essentially taking their designs and turning them into a finished product rather than letting them use the machines themselves. And that's a bit of a challenge. But that's a bit of a unique thing in our environment. Generally, we're sort of the teach the person to fish instead of the fish market. And the other important thing that we are, in addition to that large physical space and the tools and resources for the students, is we're a community. We're a community for the people that work here, for all of the students and the projects and the systems that support them, but also for our campus and all the other people who work with students who make things. Steve, you and I have interacted in some different environments around that. Tim, you and I have worked together supporting the blacksmithing club and a few other project teams. When people are looking for a resource that we don't physically have in the Wilson Center, we like to say that we're a space that we can sort of launch the students out to find on campus or maybe in the wider community the resources that we don't have available for them. And that's a really important part of what we do is kind of curate that wider community that provides that access for students and advocates for it.
So you have milling machines, lathes, probably the manual ones. You probably have CNC versions. You have welding shops. You have electronic shops. Just looking around, I see lots of tools, lots of wires. And I even see people doing, fiberglass and carbon fiber layup. The solar car team is down there. That's kind of a special one, I guess, because they probably raise more money than any of the other teams. Is that true?
It's the solar car team it's definitely our largest budget project, and a lot of that is purely driven by the materials that they use and the competition they participate in. So, solar cells, batteries, electric motors, inverters, large amounts of carbon fiber. These are really expensive materials, and they travel to Australia every 2 years for an international competition. And that project alone has a pretty big price tag.
Can you tell us in round numbers?
The solar car team's budget is a couple of $1 million for a project cycle, and they do 2 races as part of their cycle. They design and build a car for the Australia race, which is broadly considered the most competitive race, and then there's an American Solar Challenge that happens on the alternating years, and that race is very challenging because of its length, distance-wise, the duration of the race, and the change in terrain. But the competition of that isn't quite as fierce as it is for the Australia race.
So what other kinds of competitions do you?
So
I realize you can't remember all of them, but
yeah, I mean, it spans from, like I mentioned, the Mars rover, which is very much like a vehicle that would go to Mars, and it has these remote controlled and autonomous functions. It's unmanned, of course. We have a concrete canoe project, which a lot of
do that one.
material science students get involved with. Yeah, which is really neat, and people sort of scratch their like a concrete canoe, and it's one of the oldest intercollegiate design competitions. And concrete is a very challenging material, and it's really a great way to illustrate, I think, the value of these projects, because that project you have material science engineers alongside civil engineers. That project has a really strong artistic component. They actually get evaluated on the graphical presentation of the canoe. There's a theme for the boat every year that the boat itself and all of the display materials sort of align around this theme. You'll get art and design students involved in that project. We have a lot of robotic projects, things that fly. We have aircraft, boats, submarines. We have a lot right now of electric vehicle projects, and those are sort of illustrating how our students can really push us in our sort of willingness to support and advance what they're doing, because they are on the very cutting edge of a lot of these technologies. Right now, the space where we're sitting is normally occupied by a 22-foot long electric-powered racing boat. It has a custom designed and fabricated battery pack with over 4,000 of the Samsung cylindrical lithium-ion battery cells inside. They're in Florida, testing the boat right now with one of our corporate partners at one of their facilities. And this boat, probably more than anything, has kind of pushed the envelope for what we can physically support in terms of the size and scale of a project, but also, the complexity and the risk of a project, because that battery system, it holds an awful lot of energy. And we've had a lot of conversations with the other experts on campus who are helping us and the students understand, okay, what's appropriate for us to do right here on campus. And there aren't a lot of broadly accepted standards for electric vehicles right now. And so the students are literally kind of in this Wild West, landscape with a lot of the, OEMs and other people working in that space.
Could be really dangerous.
It can be, but that's also the fascinating thing is our students are among, the experts in this, is they've been doing internships and working with, companies that are also producing this technology. And so the students come with that experience, and they sit down with our faculty who are also on the cutting edge of research in this area and help define, right, what are the boundaries for this look like. So that's been really exciting to see that project kind of test us in ways that I haven't been tested since I've been here.
It's very cool that the students get to work on problems that aren't solved yet, because in so much of their coursework, they're learning to solve solved problems, and this gets them out of that space, and I love it. You started to mention earlier the community aspect of the interactions that come from people coming through here, and I want to turn that into the next question of why have a sort of monolithic project center? Because at other institutions, individual departments may host shops or maker spaces or things like that, but you have this sort of modular, but essentially all under one roof. aspect. And so what are the benefits and drawbacks of that monolith model? And then what are the impacts that you see on the students who come through here as a result of that?
So the monolithic model, it's great because it's a beacon, right? Here's this one place that everyone says, hey, I want to, as a student, as an undergrad in engineering, if I want to make something, here's the place that I go. This is the front door for that infrastructure on the campus. And so you get a lot of the the benefit of the students working together here. A new project team sort of sees a lot of possibility because they look across the aisle at a team that's been here since the 80s and say, wow, okay, here's a lot of experience, a lot of confidence in innovation and taking risk. And you can generally say, hey, if I'm going to adopt a new material or a new technology, I can probably look around the room and find somebody else that's doing that. And that's the benefit of having, the Solar Car project right next door to our rocket team, and our model aircraft team is sort of in the same hallway. And so these projects can all kind of feed off each other. I think that's one of the big benefits, is it lowers, I think, the perceived risk that students have of adopting these new technologies or techniques or materials.
It's a really good illustration of just the interdisciplinary spirit of Michigan in general. This is really, I think, part of our institutional ethos, is that we try to not be siloed and we try to be very multidisciplinary in our approach to solving problems. And this is a perfect implementation of that principle.
Yeah, exactly. And I think that's one of the core, that really goes to the reason, right? Why do we do this? And it allows students to come together to work on projects from this multidisciplinary perspective, right? We still fundamentally have a department-based, sort of a siloed structure, right? You have these traditional roles for different flavors of engineers. Our robotics department is kind of breaking that mold a bit, and the Wilson Center, we're really proud to be part of that, because I think our philosophy and the way robotics was created fits together really well. But that's one really big value, is, hey, you get all these students from different disciplines working together. The other core value I kind of alluded to a minute ago is this idea of exposing students to risk, because we're in this, essentially, it's not unconstrained, but it's a less constrained environment. They're given a set of requirements from a competition and said, here's what your project needs to demonstrate. Here are the deliverables that we're asking you to, and here's sort of the parameters that you need to work within, and go forth and see what you can do. And so the students are able to, in a way I think a lot of our students have never really experienced in their previous academic life. They can take a lot of risk, and they can fail. And that, to me, is what I'm really proud of, is that we have, an institution that embraces the risk, and that we have a culture that says, yeah, we value the experience of these projects over the accomplishment of the project, right? It's not about the trophy, what the students bring home. It's important to recognize and celebrate that, but it's also important to recognize and celebrate when things didn't go as planned, because that's engineering, right? And so for us, that really, I think, is the most important thing that we offer, is a space where the students aren't getting a grade for what happens at the end based on did you succeed or fail. It's all based on what did you learn. And so that's really...
So right now, students get no credit for this in most departments.
Not structurally, that's correct. So we do have, so a good example, I mentioned before, we have capstone design projects that are often embedded within these teams. Like our Baja team, their four-wheel drive system was an ME450, capstone project for some of the students. Last academic year, about 10% of our students on these project teams were getting credit through our multidisciplinary design program, which is a framework that we have for students to get credit for project-based work, either internally to the university or with external corporate partners. And we do a lot of work with the faculty director for that program, who's one of our professors of practice, a retired engineer from GM. He's our Chuck and Ann Hutchins professor of practice. So Harvey Bell is his name, who works really directly with a lot of the students and brings that corporate kind of engineering requirements driven approach to a lot of the work.
That's for the MVP projects.
For MVP,
Are there faculty advisors for like the Mars rover and the solar car?
there are, and so those faculty advisors come from all of the different departments across the college. Harvey is actually a faculty advisor of record for some of the project teams as well, and sometimes they'll have a co-advising relationship. Faculty advisors have different levels of engagement. Some of them bring their discipline-specific knowledge and are very heavily engaged with the teams. And others sort of play this, backseat role and say, if you need something from me, come and find me. Otherwise, you can find me in my research lab, and you all go do what you do and let me know how I can support you.
But I guess there's also a lot of corporate memory comes because you have second year, third year, and fourth year students on teams, and as some cycle off, the other ones kind of know what's going on and help train the younger ones. Is that embedded in most of these teams?
It is, and that's one of the things they struggle with, right? Is this, how do we teach? They have to devote a fair amount of their bandwidth to sort of teaching the new members some of these skills and processes that either they won't get, for 2 or 3 years in the curriculum, or they won't really see at all, right? As some of these unique, experiences. So that's a load, on the students to do this training, but it's an important thing for them to develop the skill to do that. And but that, Steve, is really one of the other real powerful benefits to this experience is, it gives the students these sort of less structured problems. It lets them, experience risk in real ways, and it also lets them do it over a multi-year experience. And most of the students will join a project team in their first year, and they'll stay on the team for their, entire undergrad experience. And so it gives them that iteration that you just can't effectively get in the curriculum. And so it's essentially a 4-year-long, capstone project for a lot of these students. And they evolve in their knowledge and also in their positions on the team. So I'll tell a lot of our corporate sponsors who come to visit, it's sort of like an engineering career squashed into a 4-year undergrad experience, because they start out, hey, here's a very specific defined role within this team. And as you move your way up in the structure, you become a sub-team leader responsible for other people and this educational component. And eventually you're, one of the senior leaders of the project team, where if I see you in the machine shop actually producing something, I'm going to say, hey, that might not be the role you want to embrace right now. Now you're in this leadership role, and we need you to appreciate the importance of that. And now your focus is almost as much or more on the people and on sort of the management of the project as it is on the specific, mechanical and physical deliverables for the team. And that's a really hard transition for people in general to make. And we're talking about undergrads. I mean, they have to learn how to trust and delegate, and those are critical skills for engineers in industry, but as an undergrad, they're not put in that position very often. So.
Yeah. The student-driven nature of the interactions and the team dynamics here is really interesting when we compare across some different institutions that have various kinds of project spaces, because some are entirely student-led and managed and organized. Some are very top-down, faculty or even administrator-driven. And it seems like the model here is sort of a hybrid of both, where within the teams, the students have a lot of agency to determine how the team runs, but within the Wilson Center itself, the Wilson Center is not managed by students.
Yes, yeah, that's correct. And it's fascinating because when we go, there are a couple of academic conferences essentially for student academic makerspaces, and you can see in the room, right? Here's how the different philosophies kind of migrate to the different corners, and there's a lot of it is driven by the institution. And when people ask, hey, what's your secret sauce? I'll say, hey, the recipe is really strongly influenced by your institution and the risk tolerance and the relationship that you have with your campus environment, health and safety department, or whatever the equivalent is there. We have a really strong relationship with our EHS department here. I view them as a partner that probably comes from my aviation safety background, where everybody embraces, these failures. We're like, hey, we're not here to find fault. What we're here to find is a root cause so we can prevent, right, that from happening in the future and capture those lessons learned. And so So that's how I think it's not driven as much by the people as it is by the institution, I think, in that enterprise sort of tolerance. But you're exactly right. And that's one of the things we pride ourselves in, is giving the student organizations here, whether they're ones part of the Wilson Center or there are sort of non-project based organizations, you give them a lot of autonomy, right? To sort of manage themselves, to define their own course. We're there to provide that support. One of my closest partnerships on campus, besides EHS, is with our student affairs division. So there's an office there that is exclusively designed to support all of our student organizations. And so that group and I meet every week. We're sort of, we're sharing notes, say, what's the boat team up to this week? And, where are you seeing conflicts? And so we work really closely together to help enable that. And we each have sort of the lanes that we operate in, but there's a lot of overlap in making sure these organizations are successful, because it's about the people and about the access to the resources internally and off the campus that are really important for their success.
How many students are involved in the Wilson Center every year?
So we have so last academic year we had about 1,600 students that had completed the training that we require for students to get M-Card access to the facility.
So that's like 20% of the engineering school.
It's a
right?
it's
That's
a big
group.
It's about
amazing.
90% engineering undergrads,
Yeah.
and the other 10%, grad students, other schools and colleges. But yeah, so it's about
And as great as that is, wouldn't it be better if you could triple that?
well, it would be great, right? To be able to have a larger population. And I think aspirationally, as a College of Engineering, we would like all of our students to have an experience like this, right?
Right, an experience where it's safe to fail forward, where they will learn to be professionals and not just students. And also just to have the fun of getting their hands dirty. There's still something very real about that tactile experience of building something that doesn't translate to a lot of classroom experiences.
Yeah, and that's the funny thing. I just had a conversation the other day with our manager here about the project that we use for students who come in to get that access. We have different projects at the Wilson Center and at the robotics makerspace, but the project here is a little aluminum pencil holder. So, the students, we do some online modules in Canvas, and they come into the shop with a plan in how to use the different tools to produce this thing. We give them a little toolkit and the raw materials, and they have to go use, a metal brake, a shear, a punch, a drill press. They have to tap a hole and
measure.
And measure, right? And so we give them a CAD model, and I keep coming back in my mind like, hey, is this project really relevant? It's a metalworking project. And when you look at the variety of projects and the students who come in the door, does a computer science student really get to embrace the value of this project? And we don't require everybody that comes in to use the Wilson Center to complete this project, but obviously a huge proportion of the students do. And the value in it, I think, for an engineer is they learn that, hey, I start with this perfect CAD model, and turning that into something real, that just using a bandsaw, getting the cut exactly where you measure, like how wide is that line on the Sharpie? And how do I get this? And, drilling and tapping a hole, you're like, at 1 out of 10 times, the tap breaks. It just happens, And so, going to the break and putting a 90-degree bend in a piece of aluminum, the uncertainty in that, for students to really appreciate that as an engineer, you're like, yeah, you can come up with this perfect design and you can model it all day long in CAD, and in 1 hour in the shop, you can walk away just with so much frustration. And so for us, that's really, kind of circling back to this building community piece, that's one of the really challenging things here, is to make sure that everybody comes through the door that has an aspiration to be part of one of these projects, doesn't view the environment as a barrier, because so many students didn't grow up doing this. I did, tinkering with cars and airplanes and all these other things, but so many students, they don't have that experience, but they still want these kinds of experiences, because this is a showcase thing that we show to every student who comes to campus. you walk by the Wilson Center, you come through, take a look at these projects. This can be part of your experience. So to make sure every student that comes through the door sees that pathway. And our front door, literally the first thing you see when you walk in is our two big Haas, CNC machine tools. And so that can be a super intimidating, oh, they just want to turn around and walk away, kind of an environment. So that's really all about kind of empowering our student staff, who are really the front door to the community, right? And making sure they understand that, hey, your role here is to help people be comfortable in the space and to provide, the support for them in doing this project or in engaging with the resources we have kind of where they're at. And that's the value of sort of not over curating the experience, is kind of let it meet the students where they are and staffing to do that.
So can you talk a little bit about the impact of this experience on the actual students? Does this help them get jobs? Does it help them get better jobs? Does it allow some of them to start their own companies? What happens to the students who go through this that you've seen? And I don't know if you've studied this, but even anecdotally.
Yeah, and it's all of those things, obviously, Steve. So we know that a lot of the internship and job experiences that students get are strongly influenced by their participation on a project team. We hear that from the students, and we hear that from the corporate sponsors, right? They'll every chance they get, they say, hey, yeah, if we get, we're looking at 2 applicants, and we've got, a 4.0 student, and then we've got, a 3-point-something student that's got one of these student team experiences. We're usually going to take that, resume first. And if it's that kind of a role, they look at that and say, yeah, that there's value as an engineer in breaking stuff, in getting your hands dirty and applying what you learn in these kinds of environments. And it's reinforced, by the alumni that go out and they come back and they say, hey, I'm here for the career fair. I want to come to the Wilson Center and collect resumes, right? This is where I want to be. We do have students that have gone to found, companies. So a lot of entrepreneurs that started their journey here, and they're very generous in coming back and sharing, some of their experience and the hard knocks they continued to see after they left. But
you're successful when your alums come and give you money, or help a team by giving a team money. And
Yes.
I imagine that's already happened in a short time.
It's happening a bit, and it's the interesting space that we're in. I think in my mind, we're 25 years old. I mean, we're very mature. But when you look around the campus at buildings that have people's names on them, most of those people, project teams were not part of an undergraduate experience when they were students here. And certainly Vince Gorgos, who was a metallurgical engineer when he was an undergrad, when he and his family came back and made the gift to expand the Wilson Center, this wasn't part of his experience. But he looked at, the impact it had on students and what he thought an engineer should be, and said, yeah, this is absolutely the kind of thing that we should support.
That's great. With the connection to alumni coming back and wanting to interact with the current students, also maybe chip in a little bit financially, I'm thinking about the audience who might be at other institutions and saying, okay, what if we want to expand or develop our program, get our makerspaces more robust, but also more well-funded, honestly. How do you do some of that community engagement and, interacting with corporate sponsors? How does that side of the ecosystem work?
Here at the university, we're really fortunate because the auto industry is right next door. And so those kinds of industries can directly see the experience the students have here translated into their workplace, right? So that, I think, in a lot of ways makes it easy for us, because the automotive industry and all of the suppliers associated with that influence is really strong. But the other thing that helps us is we partner, right, with all of the other sort of institutions on campus that promote those external engagements. And so we work really closely with our sort of the college corporate relations world, but our students are part of all the academic departments on campus, and every one of those departments they're doing the same thing. They're telling the story about the experiences of their students. They're amplifying those messages within their networks and with the way they advertise and talk about, what value they provide and what, a donor could do to help influence that. So we leverage that pretty heavily. We don't have our own communications and marketing team. We use all these other pathways, right, to sort of talk about what we do. But for other institutions, I think it really starts at that level of, okay, well, think about, your alumni, where are they, and how can you help them see what students with these experiences do when they get into their environment. I mean, it's telling that story, and the students tell the story the best, right? You just need to give them a platform and sort of the professional packaging, to do it in a really compelling way. But their narratives are, you can't beat those, right? You can't write anything better than the way they talk about the experiences themselves. So you got to give them that platform.
I think it's important also to remember that we haven't mentioned this yet, but all of our engineering students, as first-year students, take Engine 100. And that's not even this project center. They don't do that here. They do that elsewhere.
Yes.
But this is in addition to that massive undertaking of giving every single student an opportunity to do design, build, test, and repeat. Tim teaches one of those.
Yep.
But that's a totally different endeavor, because I've been to some schools where they'll show you this space and say, this is where we do our freshman, engineering course. This is where we do our projects teams. And this is where we also do our capstone design. But this is very special. This is specialized. You said it does some capstone design, but it's really focused on all of these teams. And this whole facility is kind of separate from those other two endeavors.
Yeah, and I think there would be a lot of value in, sort of co-locating them. And that's something that, when we worked with robotics on the space there and sort of designing that, one of the things that we really focused on initially was saying, hey, we shouldn't be duplicating a lot of these sort of high costs, relatively low utilization resources. We just open the door and say, hey, we've got, a CNC machine tools here. We don't need those there. If a student needs that capability, bring it down here. Let's put something there we don't have. Let's, get a fiber laser and a CO2 laser, and let's get a small water jet, and let's concentrate 3D printing resources there in the various different modes. And so that's one of those values of viewing the role of one of these spaces as not just the resource provider, but as this sort of on-ramp to those resources around the campus. And so you can advocate for the sharing or the distribution of these resources to make it more broadly available. And space is the thing we all struggle with. And so, you'd love to have, one or two of everything in your shop, but maybe it's better to move one or two of them up the hill and make sure the students know what the pathway there looks like, to kind of promote that.
So I was on a committee that Dave Bunsen, one of our former deans, put together back when he thought he was going to get a building over in the parking lot that's not there. But it was the shop committee. Remember that?
I do. Yeah.
And one of the things we realized was we have lots of little shops in different departments, and we still have those in a large way. But it seemed like one of the biggest barriers was training, because everyone to use a new shop had to go through their process of training, and there were so many redundancies. If we could just agree on one system of training, it would allow the utilization of all of these facilities. But that would kind of mean putting it all under one person's direction. And that's it. They never got the building. It all fizzled. Hopefully some of those things we learned, because you were involved with that, and hopefully that's been incorporated with some of the things with the robotics.
Well, and that was really how the relationship with robotics started, was sort of when they realized we're going to have this building and we're going to create a department and we want to have a makerspace here. I knew, the managing director there, who was sort of, talking, and said, well, would you help us with the design? Like, here's the space we have. How should we lay this out? And then it went to, well, what kind of tools should we have there? And what's the power and ventilation? And then it was, well, what about staffing? And what about training? And wouldn't you just like to come do that for us, right? Because you already have a model that appears to be successful with our community. And so there were a few people at the time that were like, why do you want to do that? You've already got enough, right, in the Wilson Center to keep you busy. You're going to dilute, your perspective, and now you're adding all this complexity of just having another physical place and different people in a different community to serve. But fundamentally, it was exactly what I felt like, I was asked to do when I first came, was just, okay, we need to build out, it goes to what this committee was trying to envision. Was, hey, let's create a network of spaces around the campus that have a common path to entry, where you open up the catalog and you say, here are the things that are available, here's what I need to get there, and I can all start at one spot. And it's sort of a coherent path. And that's what we've been able to achieve, and it's fun. I can see the impact of that directly in the 3D printing system that we have up there. We have these different types of printers, and we've got this queue. So we know, okay, everyone that comes to use it, who are they, where are they from, which tool are they using? And even though it's in the robotics building, which is really right up the street, but it's a different physical space, in really the 3 years that we've been fully operating, half of the users of our 3D print queue in robotics are student project teams. So they're here in the Wilson Center, or they're in, and there's a sizable chunk of use directly from robotics, the academic courses and the research faculty, one of whom owns one of the 3D printers we have in the space there. Her lab bought the machine and said, we want to put it in the makerspace for the community to use. We'll buy it if you guys maintain it and train it. And it's like, yeah, great arrangement. And then we've also got this chunk of people that are just coming from all over the campus. And we sort of, that space, I joke, we've become our own worst enemy because we print things for free. And now that I've said that, on the podcast, right, the line's forming.
We'll edit that out later.
Yeah, please do. What did I do? Sorry, boss. So now people come from, kind of all over North Campus, and they come to use these resources, and you can tell it's when, you get a biomedical student that comes up. Well, they have the exact same 3D printer in BME, but, at that time of the semester, their resource is full. Or, there's a time when someone else's resource is down for whatever reason, now they've got another place they can come. Well, yeah, come on up, and so we've created this, kind of a structure that other institutions have done really well. MIT is a great example of there's this network. You kind of plug in and you can move around, and it's all of these little distributed shops that, you can go visit once you get onto the on-ramp.
So we keep circling around the same sort of thing. I know when I talk to high school kids who are thinking of coming to college, or even freshmen, when they come in to declare our department, there is a massive desire to make stuff. Engineers want to make stuff. And I almost feel like, we do a pretty good job of letting them do it, but there's probably more demand than there's actually space and time and equipment for as many. And, Tim and I, 2 years ago, we were at a conference at San Luis Obispo, a much smaller university than ours. I don't think they field more than 10 or 15 projects compared to the double the ones. Yet they had 3 times the physical space of the Wilson Center. It was impressive how big their space was. And how do we fix that? How do we get more space? How do we get more resources so we can even better serve the population? How do we go, like you said, so that all students can be involved, not just 20% of them?
Yeah, I think, it'd be easy to say, well, we just need, a Wilson Center that's 3 times as big. But there's, you also have to think about what the iteration of this would look like as engineering education evolves. And, it's clear from, the Associate Dean for Undergraduate Ed, who I worked for, that, hey, our goal is to integrate more of these kinds of experiences within the curriculum. And what that really looks like within, the scale of 128 credits or whatever parameter we're going to use as a constraint, I think that's still kind of to be determined. But I think that's a bit of where this would have to go. I think to really significantly scale up, if we wanted to touch every student with an experience like this, we would have to make that compromise of saying, hey, there's a lot of value in bringing all these projects together, but it also at a certain point, it just becomes a little bit too onerous, or it makes sense to segregate certain kinds of activities. And, as we learn more about the hazards of some of the materials, so 5 years from now, I can envision maybe that some of these projects that work on a very large scale with custom battery systems might be well suited in their own very specialized facility for that, right? Projects like Concrete Canoe that generate a lot of hazardous material during part of the phase. Silica dust, we've learned a lot about the hazards of that in the last 5-7 years. And so segregating those activities in purpose-built spaces probably makes sense. But we have to be really careful about preserving that community piece, right?
Sure.
How do we keep all of these organizations stitched together? And yes, exactly. Because I think just building bigger and bigger building, at some point it makes sense to keep that broken down a little bit more specialized. I think that's the same reason that departments, in traditional engineering disciplines are still, look the way they do, because there's a certain scale that comes from putting these similar minds together but encouraging the collaboration, right, across those boundaries. And I think that's really how we can scale. I could absolutely use, a 40,000 square foot Wilson Center, but I think having these pockets of more specialized work along with specialists at various places around the campus makes a lot of sense.
So it sounds like you've preemptively answered my last question, which is, hey, what's the future of the Wilson Center? But it sounds like you're describing a vision where the Wilson Center per se is sort of this central node in a network of spaces that have a certain degree of customization, specialization based on the needs of the work that's done there, but that they can still be integrated with each other and not be fully separate. And so the mission of this place almost becomes to be the bridge that successfully connects and integrates all those things with each other.
Yes, I think that's absolutely true, Tim. And I think, training as a common thread, having kind of a professional approach and building trust, right, among the people that sort of oversee the distributed spaces is really the key to having a common pathway, or incorporating it into, E100. We have a really close partnership. We share a staff member with mechanical engineering, and so we have a very literal bridge built with kind of the second largest machine shop on campus that trains an awful lot of students who spend time here working with mills and lathes. And so I think leveraging those kinds of things is really important.
Yeah, and the other thing is, it's interesting. James hired you, and James was probably the first undergraduate dean who started pushing our whole system towards experiential learning. And he was followed by Brian, and then Joanna, and now Kevin. And forever, we're a very research-oriented engineering school. And so most of our departments have a course where you get department credit for doing research in the department. And that is another kind of experiential learning that has tremendous value. But so does this. And I wonder if there shouldn't be some thought to redesigning the curriculum, to having I know Joanna tried to do it, but I don't think it ever came out like this, that in every department's curriculum, you need to carve out 3 credits for an experiential component. That can be research, it could be working on a project team, it could be, volunteering for a sustainability project or outreach, whatever it is, but it should be something that is organized within a community, like you said, And then if it could be organized like that, that could be a powerful thing.
Well, it is, and I think we're seeing pockets of that now. Aerospace engineering with what George Hallow's doing with the model-based systems engineering lab.
Right.
It replaced required courses in the curriculum with this. What he does in the lab with project-based experiences and very strong corporate support. Big surprise, right? They're like, hey, these are exactly the students that we want to see, filling out our job applications when they graduate. So I think there is a lot of opportunity for that, but it's finding within the departments where does the opportunity exist for that. And,
I just think you mentioned using a brake to turn aluminum 90 degrees. Well, you can't do that with just all kinds of aluminum. It depends on the alloy. And, there should be a component of alloy design in a lot of the applications. And that's hard to do, but Tim here teaches alloy design in our undergraduate lab using the computer to model it. And then we have a foundry, and so the students go and make it and test it. Doesn't usually work the first time, but that's okay. But I wonder if there could be a way that with MSE we could even create our own new project that maybe TMS could sponsor.
Yeah.
A competition that'd be very material centric. That'd be a lot of fun.
I think connecting that back to the point of making space in the curriculum for all students to have a credit-bearing experiential learning opportunity, part of it is getting over the identity of our department as this is the content that you learn in this major, that we must teach our students the things that we were taught because that is what makes us who we are. And to say, maybe it's okay if different students learn different things and still have the same degree at the end of it.
Well,
That
we have
can
a lot of
have
electives.
room. Yeah.
We could give up one of our 4 electives for an experiential elective if it's connected to materials. I mean, I'm sorry, if you do alloy design, you're doing a lot of material science. So I think it could be done.
maybe we could. I'm putting my freshman engineering student hat back on again. Maybe we could get rid of a calculus class and replace that.
No, we need to add. I think I already did that. We need
Oh, you just triggered Steve. We need to
In
pivot
fact,
here.
our department is teaching a math class now. Tim's teaching it
Funny.
because the core math is not sufficient. They got rid of linear algebra. I couldn't believe it.
Yeah. Well, robotics is doing the same thing.
Yeah, I know.
So they're-
Yeah, Jesse wrote his own calculus book
Yep.
because we need to. Yeah, math is important, but so is others. So are
Well,
others.
but understanding it, right, is really the important piece. And so it's using these kinds of experiences to put those very academic subjects into a context, right? Now, this is how I apply that, how I use that. It does so much. I mean, I'm preaching to the choir. It does so much to deepen the understanding, right, of the theory.
Looking at our core curriculum is not a good move. No one wants to change that. But all of our departments have lots of electives. We have departmental electives, we have science and tech electives, and then we all have free electives. There's actually a lot of space to experiment and try these things.
Well, and like I mentioned, I mean, I see tremendous opportunity as a capstone with what the students here are doing. There's so many parallels. We get a lot of aerospace and mechanical engineering students that do their capstone or like a senior design experience embedded within some of the project teams, sort of a sub-team design or implementation.
Right.
And I think it captures probably almost all of the learning objectives that you have. It's just providing that structure and the assessment that I think is really important to figure out.
So we're getting long on time. So there's one last burning question that we've got for you. Would you like to ask it?
No, you came up with it. You should do the honors.
Okay. So you happen to be in New York City just for fun. You're staying in a nice hotel. You get on the elevator and there's like Mary Barra or some other, chief executive of a big auto company, or, maybe it's Tim Cook, and you've got 30 seconds. How do you convince them to give you $10 million to improve the Wilson?
So Mary Barra would probably be sold. She'd be pleased that, oh, it's great to meet you. I've heard so much about you. You know, where do I send the check? But yeah, the Tim Cooks of the world, probably the best way is a story that I hope I could even tell in 30 seconds. But 2013, so I was still pretty new here, and our Baja racing team, they built an off-road race car SAE competition. They had been sort of a top, 10 team for a long time. They've got a very long history, and they were really struggling. It was, how do we get on the podium? How do we get, 1, 2, 3 in this competition? And they sat down that year with our professor of practice, who from industry, and said, okay, let's just break down the requirements. How do you get points? How do you win the competition? And they pretty quickly zeroed in on part of the competition is this endurance race. All the cars on the track, 4 hours, whoever gets the most lap wins. And the key to endurance is reliability. So, okay, what takes the car off the track? Well, the chain brakes. So they had a chain and sprocket drive. And so, 4 ME students were like, oh, we can fix that, gearbox. So that year, they designed and built a fully enclosed gearbox between the engine and the rear axle. And I was here the day the students got the gears back from the Hobber. They did that off campus, but they built the housing on our Haas, VF2. The day the students put that together and turned the input shaft and the output shaft rotated.
Yeah.
And it was like this miracle moment. It's like the first time you put a Lego set together as a kid.
That's
You're
what
like,
I was
"It
just
works!
thinking
This
at that
is
moment."
Awesome. And that year, they went on to win the Mike Schmidt Memorial Iron Team Award, which is the award for the team that gets the most points across all 3 U.S. competitions, essentially the national championship. And so for me, don't you want to be part of that kind of an experience for a student, right? Have yourself associated with that. Because every student on that team is like, oh yeah, I did that in the Wilson Center, right? That's the identity. Sponsored by Walter E. Wilson, ME 1933. Yeah, so yes, that's exactly the kind of story I would tell.
That's fantastic.
It's a great story.
So I presume you're going to send us good links to put in the show notes.
I would love to do that. There's a nice story. We got a great story about the 25th anniversary with a lot of snippets from students about their experiences. And there's also a great story that our communications and marketing group did about last year's Baja team that had a lot of struggles and really captured that the experience is not about bringing home the Mike Schmidt Award. It's also about years that didn't work out and understanding why that happened. So.
Well, that's great. Well, thank you so much for being with us.
Yep, it's been a pleasure to have you.
Yeah, thank you guys. It's been a hoot to listen. I love, kind of the snippets that I take away when I listen to the podcast, and it's been a joy to be here with you guys.
All right, and to all of you listening, thank you for sticking with us. We appreciate it. And until next time, we'll see you later.
See you on the next episode of Undercooled.